Hello, everybody, and welcome to the Crosswork Router Automation Kit soft launch announcement. Today, it's really a pre-announcement of something that we're planning on having a limited availability release of in early 2024, followed by a general availability release in the latter half of 2024. So speaking to you today, we have myself. I'm the product manager for this product. We also have Sandeep Mohan, who is our software engineering tech lead, and Arvind Bhatta, who's our software engineer on this product. So to jump right in, what is the problem that we're addressing with the Router Automation Kit? Where do existing automation products struggle? There are a lot of automation solutions out there for those seeking to implement an automation solution. However, each of these solutions tend to be vendor specific and have high learning curves. So that means that our users and customers are deploying multiple versions of perhaps similar automation solutions to cater to each individual vendor type. And they're also spending their time getting to know each of these automation solutions and learning how to use them effectively. So all of that said, how do we intend to fix these problems? We're building out this Crosswork Router Automation Kit to build a package of pre-built workflows that give you out-of-the-box functionality for a set of common use cases. So the first three that we will offer in these early releases are fleet upgrade, device onboarding, and golden configuration. Each of these workflows are designed to offer multi-vendor capability, quick time to value, and extensibility. All that's to say is it shouldn't matter what you have deployed in the field. There should be one solution that addresses them all. This solution should also be pretty easy to use. Our goal is to have day one usability with each of these workflows. So you have a quick time to value. And finally, the solution should be extensible. It should grow with you as your needs change and expand. So what do we mean when we talk about the Crosswork Router Automation Kit? RAC, as we call it, builds upon NSO and the Crosswork Workflow Manager as its underlying engines. So you can think of each of these use cases, device onboarding, fleet upgrade, and golden configuration, as a set of pre-built workflows that you can leverage on day one. So you, the user, are consuming these workflows. Underlying the workflows are NSO and Crosswork Workflow Manager. So what we have scheduled for you today is a look into fleet upgrade, one of these use cases. Tomorrow we will also have a look and demo into golden configuration. But for now, let's dig a bit deeper into fleet upgrade and see a demo of it as well. So I will hand this over to Sandeep now, who will give us a technical overview.
Hi, thank you, Jesse. So I'll go over the fleet upgrade. So fleet upgrade is about router OS upgrade at scale. Fleet upgrade app developed on top of a CWM platform. It automates the image upgrade across a large fleet of devices. Cisco Crosswork Workflow Manager is an instrument that simplifies and helps to automate complex network operation. It provides a platform for creating, managing, and executing the workflows. Workflows are defined as using a standardized domain-specific language based on the serverless workflow specification. So DSL is a domain-specific language. It's simpler and more concise than general-purpose programming language. It improves the productivity and quality and easier for maintenance and reduce the development cost. So Fleet Upgrade here offers a pre-built workflow that user can readily utilize for device upgrade processes, and also CWM coordinate the execution of multiple tasks using different tools like the CWM adapters. So here we have listed our features of a fleet upgrade. So fleet upgrade can execute bulk device upgrades. It can be carried out on a single device or multiple devices. It also performs the device upgrade either one after another or simultaneously. Fleet upgrade manages the distribution, activation, and commit of new images to the targeted devices. It also performs the pre and post install check during upgrade processes. It also generates the comprehensive reports of upgrade statuses and offer monitoring as well. So on this slide, we will cover a fleet upgrade building blocks. Here I have depicted the fleet upgrade workflow phases structure. There are pre-check, install, and post-check phases that encapsulate various upgrade activities. These are implemented as a separate workflows, referred to as a sub or child workflows in CWM. The fleet upgrade functionality includes various operations in workflows to support different phases of upgrade processes. These operations are designed to facilitate the smooth execution of each phase. So let's start with the phases here. First is the pre-check. So in a pre-check workflow, this phase performs the default pre-install checks to determine if the install or upgrade operation can proceed on the device or not. Also, it allows for additional checks using customer-created mobs. This can involve running operational command or configuration specific setting as required. In an install phase, in the middle, where we have a distribute activate commit operation is part of install phase. In a distribute workflow is responsible for distributing the image to the device from a customer provided image repository server. It ensures that the correct image is available on each device. Then next is the activate workflow. Activate workflow is activating the software image on the device. It ensures that the newly distributed image becomes the active image on the device. And last one is the commit workflow. It commits the image to the active image on the device, and it ensures that the image is fully installed and operational. And the last one is the post-install phase, where we have a post-install workflow. It's a part of a post operations. It allows for checks specified in a customer-created mobs. These checks can refer to as the output captured during a pre-install checks for comparison and to determine whether pass or fail on conditions. Additionally, this particular workflow have an action can reset any configuration made during a pre-install phase. Next slide. So here is a flow chart of a fleet upgrade supported operations and order of execution. So fleet upgrade interface remains the same when interacting with the underlying controller. So this operation provides the necessary functionality to automate and manage the different phases of the fleet upgrade processes, ensuring a smooth and efficient upgrade experience. So here user can execute either all operation or can provide on a need basis. For example, distribution here. So user have an option to distribute the image to all devices during a normal operating hours. And on the other hand, user can schedule an actual upgrade operation to take place during a maintenance window. So this allows for the better coordination and minimize any potential impact on the network operations. So as you can see, fleet upgrade also can capable of dispatching notification updates to the designated location as well as to any server responsible for logging and auditing. It also possesses the built-in logic to manage the different failure scenarios and their respective responses. Next slide. So here is our demo setup. So where we have a spin up a virtual machine instances of CWM cluster and the EMS controller. We do have a XR device which is onboarded and managed by the EMS controller. So here I have used the CWM 1.1 EFT version, and for EMS I'm using a 7.1 GA release version, and on XR device I'm running 7.8.1 version, which we will use to upgrade to a 7.8.2 version. So on a fleet upgrade, we will be leveraging NS adapter in its LA release. And now Arvind will take over and run the demo of a fleet upgrade install workflow. Thank you.
Sorry, I have to. Charge is gone. We can cut this right in video.
Yeah. That is the nice thing, I guess, about this vidcast thing. We can take little pauses like this.
Okay, so
Can you go to previous slide?
Previous slide.
Demo.
yeah, so start with the So thanks, Sandeep. I am Arvind. So I am going to demonstrate what we have accomplished in the fleet upgrade program. The EMS container can upgrade router image through distribute, activate, and commit stages, and has provided the REST APIs for the same. So we have created a CWM workflow, that is a fleet upgrade workflow, which will internally call these REST APIs to execute the image upgrade on a device. On the next slide, I am going to execute these steps as part of demo. So first I'll verify all the prerequisites on the CWM admin page. Then I'll create the fleet upgrade workflow on CWM workflow page. Then I'll instantiate that workflow to start a job on CWM. So once the job started, I can monitor the job events in CWM Job Manager page. That job also sends WebEx notifications, so I will also monitor those notifications as well. Then finally, when the job is completed, I can verify the image version on the device. So on the next slide, we have a demo flowchart, which is a subchart of the previous flowchart that discussed earlier. So here, as part of demo, we'll only cover distribute, activate, and commit of that image on the device, and at each stage, we'll also get WebEx notification. On the next slide, we have a sample input which is required to execute or instantiate the fleet upgrade workflow. So this input has the device IP information and enabling the send notification flag, the target image name, and the resource ID, as well as WebEx related information. On the next slide, we have the sample output of the CWM job, which is the final output, where we'll have device result for each device upgrade operation, which will have the device IP itself and all the three stages, that is distribute, activate, and commit, and their corresponding job names, result, and state. We also have a summary of all the device upgrade, which will also show a count of total success and failed. Now on the next slide, we'll start the demo. So here we have on the left hand side, I have opened the CWM UI in a browser. On the right hand side, I have logged on to the device, and I'll check the version there, which is currently on 7.8.1. On the right below, we have this WebEx room where we'll receive the WebEx notification. Now first we'll check all the prerequisites here. So I'll go to the admin page of CWM and the adapters tab. We have both the adapters been deployed for EMS and REST for WebEx, and their corresponding workers are also running. And we also have the secret for the REST call authorization for EMS. And we have a EMS resource for the communication with the EMS controller, and also have the WebEx as a resource to handle the communication with the WebEx server. So these are all the prerequisites we have verified. Now I will create a workflow on the workflow page. So here I have already opened the workflow file. So I'll just copy the workflow ID to create a workflow template. So for that, I'll click on the create new workflow button, and I'll just put the name here and version, and I'll just click on create workflow. It will just create a template. So I'll go inside that workflow detail page, inside the code section, where I can copy the whole workflow file contents to create the fleet upgrade workflow. So right now I am copying it. So after I'll copy the whole content, I'll click on save changes, and CWM also validates the whole JSON, and then I will click done. Now my fleet upgrade workflow is created successfully. Now I'll go to the input that we need to provide to instantiate the workflow. So here we have device IP. As discussed earlier, we have send notification true. Image name is the 7.8.2 ISO image file name, and the resource ID is EMS that we already verified in prerequisite, and the WebEx related information required to send the WebEx notification. So I'll just copy this whole input JSON schema. Then I will click on this run button to open the pop-up window where I'll put in input variable section the whole content to start a job. So this will start a, when I click on run job, this will start a CWM job. So as soon as the job started, as you can see on the WebEx window, we have a initiated notification. Now I can go to the job manager page to check the job state here, so which is running. Now I can go to the job details page. So at the below of the page we have all these job events that is going on here. So we can see there is a distribution stage is going on, and I can expand that job event to get all the input and output response of the REST call. So here we have this data where we have this message and job status and all those things. So as soon as we collapse this job event, we can see that the distribute image stage has been completed and activate image has been started. And on the WebEx window also, we have also received the distribute completed notification. Now similar to distribute job event, I can also expand the activate job event and also verify the response here. I can go to the device as well, where I can see what is going on there on the device side, and on the terminal I can execute this show install request command to verify that install replace command has been executed with operation ID and the state is in progress. I can also monitor at the device the show install log ID command to check what is going on at the device level. So this activate stage will take some more time, so we'll fast forward this demo to the activate stage completion stage. So as you can see, our device has been rebooted. So I'm re-logging to the device, and on the WebEx window we also verifying that the activation completed notification we have received here. So when I refresh the job detail page, we can see the job events where activation has been completed and commit stage has been started, and I can also expand to see the response there. So when I refresh the page, I could see that the job is completed now, and on the WebEx window also we have also received the commit completed notification as well as the completed notification. Now we can go to the final output of the job, where I can expand the last job event to see the final output. As discussed earlier, we have a device result which has all the 3 stages, and each stage has the corresponding internal EMS job name, job status and job state. Now I can check this targeted version on the device, which is 7.8.2. So this completes our demo here, which is a small glimpse of fleet upgrade under Router Automation Kit. Now I can hand over to Jesse, who can go ahead with the rest of the session.
So to close out, we'll give you a brief overview of our planned release timeline for the Router Automation Kit. Like I mentioned, we're going to have a soft release, a limited availability release in April 26th of 2024, and we plan to have our general availability release in fall of 2024. So we invite you to come speak to us while we're at Developer Days so that we can address any of your problems and discuss your interest in either limited availability or general availability release. So thank you so much for your time, and we look forward to seeing you at Developer Days.